Okay, this is program number 8 in week 6. This is a very tricky program, but it has some really good examples of using the case and if statements together. So it is very good. So I think this was intended for you to figure it out for yourself, but I'm going to actually just do a complete walkthrough of it because I think it's a good thing to try to really follow what's going on here. So we'll start it again by commenting everything and then filling in for the comments, because I think that's a really good way to develop these programs. So if you look at this program, what it's saying is write a program that gets the coefficients a, b, and c of a quadratic equation. So that's from the user. That's where that's coming from. And then calculates and prints its real roots, basically solving a quadratic. If they exist. Quadratic equations can have 0, 1, or 2 real roots. So here is the conditions that we're going to use here. So we solve a quadratic equation first by determining its discriminant, or d, by the formula d is equal to b squared minus 4ac. If the discriminant is 0, then the quadratic has 1 double real root. It is calculated by the formula minus b divided by 2a. If the value of the discriminant is positive, the equation has 2 distinct real roots, which are calculated by x1 and x2 being negative b plus and minus square root of d divided by 2a. If the discriminant is negative, then there are no real roots for it. Okay, so there's a couple different strategies we need to take here. It's a lot of funky math that we're going to do, but really it's the decision making that's key to this one. And then we're going to print all the real roots of this. Alright, so let's look at our programming here. So let's lay out what we actually need to do here. So I think this question is not worded very well either. So first thing we need to do is, I'm going to be very descriptive in these ones. Get A, B, C from user. Actually, before we even do that, let's start one line earlier. We're actually going to define our variables for this one, because there's a bunch of them that we're going to use. Get A, B, and C from the user. And determine how calculate D, which is basically figuring out that discriminant. And then decisions based on value of D. And then we're going to do the case for D equals 1. Case for D equals 2. Equals 0. Sorry. We're going to call this put roots to screen. And then hold the screen. Okay, so these are all different things we need to do. So we're going to use a bunch of different variables here. So we're going to have a bunch of doubles. We're going to have A, B, C, capital D we're going to call it. Let's just call it lowercase d, just to make it simple. A, B, C, D. And then we're going to have x1 and x2. Okay, lots of variables there. We're also going to have an integer, which we're going to call check. Let's get the user to enter in A, B, and C. So enter value for A. Then we're going to do a so that's getting the value for A. We're going to repeat that for B, A, B, and C. So we have a B and a C. That's a C. That's a B. So we get all of our data. Next, we need to calculate the value of D. So looking up at the formula here, so D is equal to B squared minus 4AC. So that is B to the power of 2 4 times A times C. Plus pow. There we go. So that is basically B to the power of 2 minus 4AC squared. So I think that's good. Not exactly sure about the order of operations, so I'm just going to put some brackets around there just to be safe. Alright, so that is calculating the value of D. Just for fun, I'm just going to output the value of D just so we can see what it is. Never bad to just output variables like this to the screen, even if you don't plan on, if not asking you to. So D is equal to that. So now we're going to do a check based on the value of D. And why is this important? Because we're going to set up a couple of cases, but we need to know which case is going to run based on the value of D. So we're going to set an integer as this integer value we created called check. We're going to set that as either a 0, 1, or 2. depending on what we calculate D as. So D right now, we need to check, is it positive, is it negative, or is it 0? But we want to break that down into some things we can actually check more easily in our cases. So let's look at this now. So let's say if D is greater than 0, so positive, we're just going to say check is equal to 0, because that's going to mean so if it's less than 0, that means we have a negative. Put it here. So let's do that one. Or if D is greater than 0, which would be positive, check is going to be equal to 2. And this one's just going to be else check is equal to 1. And that one means only one root. Okay, so we set up a couple of values for this variable check, depending on what we are running for the value of D. Now we can use that, the value of check. It makes it very easy to set up a case now. So let's do case 1. This is based on check. So, case 1, this is where we have two distinct roots. No, there's only one root. So, x1 is going to be equal to negative b divided by 2 times a and x2 I think we can just say x1 is equal to x2 is equal to I think we can do that. We can do that, but it's confusing, so we're not going to. We'll just do this. x2 is equal to that. So that is case 1. Let's do case 2. So case 2 was where we had the two roots, but they're different. So this one, x1 was equal to negative b plus the square root of d. So math dot square root of d all divided by that, and x2 is equal to same thing except that's a minus sign. That's that. Case 3. Oh, sorry. Case 0. It's just console dot console right line, no roots. All right, back at it here. So we got to make sure that we are outputting. I missed that we need to output our results for each of these as well. So we'll do a console right line. This one's going to say no roots. This one is going to say the roots are those two things, and that is x1, x2. This one is going to be the root I guess we can say the roots are, but they should be the same thing. x1, x2. Okay, so I think that is, oh no, we need to hold the screen. Let's try this and see what happens. So let's think of a quadratic. I'm just going to take a little pause here and I'll get some examples. Alright, we are ready to go with this program. So let's give it a test. So and add one more thing in here, just some more text to come up on the screen so we can see better what's going on. So we say console write line here. I'm going to say the two roots are two same roots are, call this the two unique roots are. Alright, so let's give this a try here. So enter in A. So the first one I'm going to test with here, let's use the quadratic x squared plus 4x plus 4. I know that this is, if you break this down, x plus 2 multiplied by x plus 2 gives you x squared plus 4x plus 4. So that means x plus 2 multiplied by x plus 2. The two roots should be negative 2 and negative 2. So x squared plus 4x plus 4. So a is equal to 1, b is equal to 4, and c is equal to 4. Those are the coefficients of the quadratic. So it calculated d as 0. So then we go to the case. It set the check value based on what is d, is it greater than, less than, or equal to 0, and then we run the math based on that. In this case comes up with that there's only one root, so x1 and x2 are the same, so this one's actually a square. So it says the two same roots are minus 2 and minus 2. That is correct. Let's do another one. For this one, we're going to do x squared minus 2x minus 3. This should give us a 3 and a negative 1. So 1 minus 2 minus 3. This is the same as x minus 3 multiplied by x plus 3. So d is equal to 16. So a positive d gives us two unique roots, and we get 3 and minus 1. The final one, let's do the no roots. So x squared plus 4x plus 5 has no roots. So x squared plus 4x plus 5. D is equal to negative 4. That jumps us down to the case where we have no roots at all. So we get no roots. Alright, so that is all of our code. So just to do a quick review there, we set up the variables because we're going to use a bunch of variables. We enter in our data, parse it down to doubles because the doubles are what we're using. We calculate D. We do a check. We set this check variable based on our calculation of D. If D is less than 0, we're saying a check is going to be equal to 0. If D is greater than 0, we're saying check is going to be equal to 2, meaning we have two roots. And else, we are going to say check is equal to 1, which means we have only one root. So then, we are going to run some switches, and we have a case where D is equal, where the check is equal to 1, where the check is equal to 2, and where the check is equal to 0, and we run different math depending on which case we're running. and we output results based on each case. And that is our program. Okay, pretty complex, but the independent functions that we're using in there are pretty straightforward in what we've been doing so far. Okay, so tricky program, but well, this is the end of it. Okay, good luck. Pack this up, put it in your assignment. This is program number 8, final program from week number 6.